In this video, we're going to talk about section 5.4, exponential and logarithmic equations. More specifically, we're going to look at how to solve exponential and logarithmic equations. There are two different ways that we're going to solve them. One of them is called the one-to-one property. The one-to-one property is simply that if both sides of the equations have the same base, then you can just get rid of the base itself or the logarithm itself. And I'll show some examples of that. And the second one is the inverse property. So let's look at a little examples of this. One-to-one property looks like this. Notice that they both have base A. And so we can literally just get rid of the a's and just say that x is equal to y. Because they have the same base, therefore x and y must be equal also. Here we have log a, log a. Again, those could just be gotten rid of, and now you have x and must equal y. For the inverse property, what we need to do is bring it to the power of so like this one has a base of a, so we're going to put that in the power value of a as a base. So it'll be a to the power of this, and then we'll have just x left because these two things cancel out. And the reverse can be true. If you happen to have an a to the exponent, you can get rid of that base a by taking log base a of a to the x, and that will just equal x. Remember that anything to the power of some exponent, that exponent does go to the front, and then this would just cancel because they have the same base. So let's look at some other examples. Let's look at this one first. This is 2 to the x equals 32. So we can rewrite this because we know that 32 is 2 to the power of 5. And since they both have the same base, we can just get rid of that base, and it's just going to be x equals 5. That is an example of one-to-one. On this one, we can set this side equal to this side by adding the natural log of 3 to both sides. So now we have natural log of x equals natural log of 3. They're both in the same base, and again, because they're one-to-one, we can just get rid of that natural log, and now we know it's x equals 3. On this one, we know that 9 can be rewritten as 3 to the second, so we wrote it over here. 1/3 can be written as 3 to the negative x, because the negative power makes it into its reciprocal. And now, since they both have the same base, again, we can get rid of that base, and we're left with negative x equals 2. If we solve for x, we get x equals negative 2. Now we're going to look at inverse. Instead of looking at one-to-one, we have e to the x equals 7. So what I need to do is take the natural log of both sides. Since the base is e, I'm going to take the natural log. So I have natural log of e to the x and natural log of 7. Then this cancels right here. So I just have x equals natural log of 7. Here we have the natural log of x equals negative 3. So to get rid of this natural log, I need to use base e. Notice that I'm taking e to the power of this, and then on the right side, it's e to the power of negative 3. This way, this cancels, and I'm left with just x equals e to the negative 3, and you can put that in your calculator. On this one, we have log x equals negative 1. And again, since we don't know there's no base written here, we can assume it's base 10. So I'm going to take base 10 to the power of log x, base 10 to the power of negative 1, and then the 10 and the log cancel, and we're left with x equals 10 to the negative 1, or 1/10. Lastly, we have log 3x of 4, and since this is a base of 3, we're going to take it to the base of 3. So it'll be 3 log 3 of x and 3 to the 4. So this will cancel, and then we'll have x equals 81.